Welcome to this pre-recorded lecture on mediation effect definitions based on potential outcomes. In this lecture, we'll go over potential outcomes for controlled direct effects, nested potential outcomes for natural effects, and we'll end this lecture with some take-home messages. By the end of this lecture, you should be able to define average-level controlled direct effects in terms of potential outcomes. You should also be able to define average-level natural direct and natural indirect effects in terms of nested potential outcomes. Let's start with potential outcomes for controlled direct effects. In a mediation model, the outcome is a function of the exposure status and the mediator value. We can also see this when we take a closer look at a simple DAG for a mediation model. So we can see in this DAG here that there is an arrow pointing from exposure to the outcome and that there is an arrow pointing from mediator to the outcome. And this tells us that the outcome is a function of both the exposure and the mediator. When we define potential outcomes for mediation effects, the potential outcomes need to reflect that the outcome is a function of both the exposure and the mediator. The potential outcomes notation is therefore extended by also including the mediator. So YAM is then the outcome if individual I had exposure status A and mediator status M during time period T. Now let's apply this to a running example. So in this running example, our exposure of interest is childhood adversity, our outcome of interest is quality of life, and the mediator of interest here is depressive symptoms. The hypothesis here is those who experience childhood adversity may on average have higher depressive symptoms, and those with higher depressive symptoms may on average have a lower quality of life. So let's assume here that A equals 1 represents exposure to childhood adversity, that A equals 0 represents no exposure to childhood adversity, and let's suppose that M represents the score on a depressive symptom screener with a range from 0 to 60. Now let's suppose that we set the depression score to 16. Then we can define the potential outcomes as Y A equals 1, M equals 16. This is the quality of life score if individual I was exposed to childhood adversity and had a depression score of 16 during time period T. Y A equals 0, M equals 16 is the quality of life score if individual I was not exposed to childhood adversity and had a depression score of 16 during time period T. If Y A equals 1, M equals 16 is not equal to Y A equals 0, M equals 16, then we would conclude that childhood adversity affects quality of life in individual I when holding the depression score constant at 16. In practice, we cannot observe both potential outcomes, Y A equals 1, M equals 16, and Y A equals 0, M equals 16 at the same time for the same individual. This is what we call the fundamental problem of causal inference. Therefore, in practice, the solution is to compare average-level potential outcomes instead of these individual-level potential outcomes. The notation of the average-level potential outcomes is similar to the notation of the individual-level potential outcomes. The only difference is that we've now included the potential outcome in brackets preceded by E. And E here signifies that we're looking at the average level potential outcome rather than the individual level potential outcome. So in this case, E Y A equals 1, M is the average outcome if all individuals were exposed and had mediator status M during time period T. E Y A equals 0, M is the average outcome if all individuals were not exposed and had mediator status M during time period T. So for these two potential outcomes, we're assuming that either all individuals were exposed or that all individuals were not exposed. Then if the two average level potential outcomes differ from one another, then we would say that on average, the exposure affects the outcome when holding every individual's mediator value constant at the value m. The difference between those two average level potential outcomes is also called the controlled direct effect. And the controlled direct effect is the difference in the average outcome if everybody had been exposed versus not exposed, while holding everyone's mediator constant at the same value. So let's apply this to our running example. And let's suppose again that we hold the depression score constant at 16. Then E, Y, A equals 1, M equals 16 is the average quality of life score if all individuals experienced childhood adversity and had a depression score of 16 during time period T. E, Y, A equals 0, M equals 16 is then the average quality of life score if all individuals did not experience childhood adversity and had a depression score of 16 during time period T. If then these two average level potential outcomes are not the same to each other, we would conclude that on average, childhood adversity affects quality of life when holding every individual's depression score constant at 16. In practice, we are unable to estimate the potential outcomes in a situation where all individuals in the population were exposed or all individuals in the population were not exposed. So instead, we estimate the average potential outcomes conditional on exposure and mediator values. This extends the potential outcomes notation. So we now see this vertical bar in our potential outcomes notation. And this tells us that Y is conditional on A equals 1 and M equals M. So this potential outcome is the average outcome among individuals who were exposed, so A equals 1, and had mediator status M during time period T. The second potential outcome again has that vertical bar in it, which tells us that the outcome is conditional on A equals 0 and M equals M. So this is the average potential outcome among individuals who were not exposed, so A equals 0, and had mediator status M during time period T. The controlled direct effect estimate is then the difference between these two average potential outcomes. So it's the difference between the average outcome conditional on A equals 1, M equals M, and the average outcome conditional on A equals 0, M equals M. If these two average potential outcomes differ from one another, we would conclude that there is a direct effect of exposure on the outcome when holding the mediator constant at value M. If the two potential outcomes are the same, then we would conclude that the exposure has no effect on the outcome when holding the mediator constant at value M. So let's apply this to our running example. And let's suppose again that we hold the depression score constant at 16. Then the first potential outcome is Y conditional on A equals 1, M equals 16. So this is the average quality of life score among individuals who experienced childhood adversity, so A equals 1, and had a depression score of 16, M equals 16, during time period T. The second potential outcome is the outcome conditional on A equals 0 and M equals 16. So this is the average quality of life score among individuals who did not experience childhood adversity, so A equals 0, and had a depression score of 16, so M equals 16 during time period T. The controlled direct effect estimate for the effect of childhood adversity on quality of life when holding the depression score constant at 16 is then estimated as the difference between these two potential outcomes. Please note here that we can set the depression score to any value. So maybe we're interested in the controlled direct effect estimate when holding the mediator, so the depression score, constant at 0. Then we would set M equal to 0. We could also set the depression score to, for example, 25. So it's really up to you as the researcher to determine what this value of M is going to be. Controlled direct effects have a few important strengths and limitations. A first strength is that controlled direct effects can be used to inform policy and interventions. And specifically, policy and interventions on mediators that we can set to a specific value for everybody in a population. Controlled direct effect estimates also require less strict no confounding assumptions than some of the other mediation effect estimates. So if some of the no confounding assumptions are violated, we may still be able to estimate controlled direct effects in situations where we're not able to estimate natural effects. Controlled direct effects also have a few limitations. For example, their practical relevance is limited when it's not feasible to set a mediator to a specific value in the complete population. And in most models, we can also not use the controlled direct effect to decompose the total effect estimate into an indirect effect estimate and a direct effect estimate. So if we're interested in studying mechanisms underlying the total effect of an exposure on an outcome, the controlled direct effect estimates may not be our effect estimates of choice. To summarize, potential outcomes for controlled direct effects are a function of both exposure and mediator values. The controlled direct effect is the direct exposure outcome effect when holding everyone's mediator constant at the same value. Controlled direct effects can be useful to inform policy and interventions when we have a mediator that we can set to the same value for everybody in the population. Let's continue with nested potential outcomes for natural effects. The average potential outcomes that we've been working with in the first part of this lecture, so y a equals 1, m, and y a equals 0, m, do not reflect that the mediator is affected by the exposure. If we want to define average causal direct and average causal indirect effects, we need to use nested potential outcomes. And nested potential outcomes are based on potential mediator values. Potential mediator values are the mediator values that are observed under specific levels of the exposure. So for each individual, we can define two potential mediator values. ma equals 1 is the mediator value when individual I is exposed during time period t. And ma equals 0 is a mediator value when individual I is not exposed during time period t. Nested potential outcomes are a function of the exposure status and this potential mediator value. Based on these potential mediator values and the combination with exposure values, we can define 4 nested potential outcomes. The first one is a potential outcome where A is set to 1 and M is set to the value that would be observed when A is equal to 1. So in other words, this is the average outcome if all individuals in the population were exposed and everyone's mediator took on the value that would have been observed when exposed. The second potential outcome is y a equals 0, m under a equals 0. This is the average outcome if all individuals in the population were not exposed, and we set everyone's mediator value to the value that would have been observed had they not been exposed. Then we have y a equals 1, m under a equals 0. This is the average outcome value if all individuals in the population were exposed, while we set everyone's mediator value to the value that would have been observed had they not been exposed. And then finally, y a equals 0, m under a equals 1. This is the average outcome value if all individuals in the population were not exposed, while we set everyone's mediator to the value that would have been observed had they been exposed. Now let's apply this to our running example. And let's remember, in our running example, depression score was the mediator of interest. So there are 2 potential depression scores that we may observe for each individual in the population. The first one is ma equals 1. This would be the depression score if individual I experienced childhood adversity. MA equals 0 would be the depression score if individual I did not experience childhood adversity. Using these two potential mediator values, we can now define the four nested potential outcomes. The first nested potential outcome is Y for A equals 1 and M under A equals 1. This would be the average quality of life score if all individuals in the population experienced childhood adversity and everyone's depression score took on the value that would have been observed had they experienced childhood adversity. The second potential outcome is the outcome value under A equals 0 and mediator under A equals 0. This is the average quality of life score if all individuals in the population did not experience childhood adversity and everyone's depression score took on the value that would have been observed had they not experienced childhood adversity. The potential outcome Y under A equals 1, M under A equals 0 is the average quality of life score if all individuals experienced childhood adversity and everyone's depression score took on the value that would have been observed had they not experienced childhood adversity. And then finally, the potential outcome Y under A equals 0, M under A equals 1 is the average quality of life score if all individuals did not experience childhood adversity and everyone's depression score took on the value that would have been observed if they did not experience childhood adversity. The nested potential outcomes are then used to define two natural direct effects and two natural indirect effects. Before we dive into these natural direct and natural indirect effect definitions, I want to provide a little note on terminology. Sometimes in the literature, natural direct effects are also referred to as average direct effects, and sometimes natural indirect effects are also referred to as average causal indirect effects or average causal mediated effects. Throughout this lecture, I'll be using the terms natural direct effects and natural indirect effects, but please note that if you see these other terms in the literature, it refers to the same effects. Natural direct effects are defined based on the contrast between two nested potential outcomes in which the exposure value differs while the mediator values are held constant. The pure natural direct effect is defined as the difference between a potential outcome where A is set to 1 while the mediator is set to the value that would have been observed under A equal to 0, and then compared to a potential outcome where A is set to 0 while the mediator is set to the value that would have been observed when A is set to 0. So we can see here that across these two potential outcomes, the value of the exposure differs while the value of the mediator is held constant at the value that would have been observed had everybody in the population not been exposed. For the total natural direct effect, we compare a potential outcome where A is set to 1 while the mediator is set to the value that would have been observed for A equals 1, compared to a potential outcome where A is set to 0, where the mediator is set to the value that would have been observed had A been set to 1. So again, the value of the exposure differs across these two potential outcomes, while the mediator is held constant at the value that would have been observed under A equals 1. If we go back to our running example, then the pure natural direct effect is the difference in average quality of life score if all individuals were exposed to childhood adversity versus not exposed to childhood adversity, while everybody's depression score is set to MA equals 0, where MA equals 0 is every individual's depression score that would have been observed had they not experienced childhood adversity. It is important to note here that if we had a database of individuals, that MA equals 0, so the individual's depression score that would have been observed did they not experience childhood adversity, will differ across individuals. So for each individual in the data set, we set the mediator to the value that would have been observed for them had they not experienced childhood adversity. The total natural direct effect in our running example is then the difference in average quality of life score if all individuals were exposed to childhood adversity, so A equals 1, versus not exposed to childhood adversity, so A equals 0, when everybody's depression score is set to MA equals 1. So in other words, we set every individual's depression score to the value that would have been observed had they experienced childhood adversity. Natural indirect effects are defined based on the contrast between two nested potential outcomes in which the mediator value differs while the exposure is held constant. The pure natural indirect effect is defined based on the difference between a potential outcome in which the exposure A is set to 0 while the mediator is set to the value that would have been observed had A been equal to 1, and a potential outcome where A is set equal to 0 while the mediator is set to a value that would have been observed had A been equal to 0. The total natural indirect effect is defined based on the two potential outcomes where in the first potential outcome A is set equal to 1 while the mediator is set to the value that would have been observed had A been equal to 1, and a potential outcome in which A is set equal to 1 while the mediator is set to a value that would have been observed had A been equal to 0. It's important to note here that in both the pure natural indirect effect definition and the total natural indirect effect definition, we now allow the value of the mediator to vary. So we allow it to vary from the value that would have been observed had A been equal to 1 to the value that would have been observed had A been equal to 0. In our running example, the pure natural indirect effect is the difference in average quality of life when everybody's depression score is set to the value observed when exposed to childhood adversity, so MA equals 1, versus the depression score when not exposed to childhood adversity, so MA equals 0, while the direct effect of childhood adversity on quality of life is held constant at A equals 0, where A equals 0 represents no exposure to childhood adversity. The total natural indirect effect in our running example is defined as the difference in average quality of life when everybody's depression score is set to the value observed when exposed to childhood adversity, so MA equals 1, versus the depression score when not exposed to childhood adversity, so MA equals 0, while the direct effect of childhood adversity on quality of life is held constant at A equals 1, where A equals 1 represents exposure to childhood adversity. It's important to note here that the definitions of total and pure natural indirect effects and natural direct effects allow for exposure-mediator interaction. And exposure-mediator interaction is a situation where the magnitude of the mediator outcome effect varies across exposure values. So in other words, the magnitude of the mediator outcome effect might be stronger or less strong depending on the value of the exposure. Exposure-mediator interaction also means that the magnitude of the exposure outcome effect varies across mediator values. So again, the magnitude of the exposure outcome effect might be stronger or less strong depending on the mediator value. In the absence of exposure-mediator interaction, the total natural direct effect, pure natural direct effect, and controlled direct effect will all be equal to one another. In this situation, we just simply refer to the direct effect estimate as the natural direct effect estimate. In the absence of exposure-mediator interaction, the total natural indirect effect and pure natural indirect effect will also be equal to one another. And in this situation, we refer to the indirect effect as the natural indirect effect. This means that in the absence of exposure-mediator interaction, we can decompose the total effect of exposure on outcome into a natural direct effect and a natural indirect effect. Natural direct and indirect effects have a few important strengths and limitations. A first strength is that it can be used to decompose the total effect into an indirect effect through the mediator and a direct effect not through the mediator. Thereby, natural direct and indirect effects provide insight into the mechanism through which the exposure affects the outcome. Natural direct and indirect effects also allow for exposure-mediator interaction. Even in the presence of exposure-mediator interaction, we can use natural direct and indirect effects to decompose the total effect into either the pure natural direct effect and total natural indirect effect, or the total natural direct effect and the pure natural indirect effect. When there is exposure-mediator interaction, we cannot use controlled direct effect estimates to decompose the total effect into an indirect effect and direct effect. Natural direct and indirect effects also have an important limitation, and that is that they rely on 4 no-confounding assumptions, which may not always hold in practice. These 4 no-confounding assumptions are that there cannot be any unmeasured confounders of the exposure-mediator effect, no unmeasured confounders of the exposure outcome effect, no unmeasured confounders of the mediator outcome effect, and then finally, no confounders of the mediator outcome effect that are affected by the exposure. And especially this last assumption may not always hold in practice, which means that we may not always be able to estimate natural direct and indirect effects. This is a situation where we might need to consider other types of effects, like the controlled direct effect or interventional direct and indirect effects, which rely on fewer assumptions. To summarize, natural direct and indirect effects are defined using nested potential outcomes. In nested potential outcomes, potential mediator values are nested within potential outcomes. Natural direct and indirect effect definitions allow for exposure-mediator interaction. This brings us to the take-home messages. The first take-home message is that controlled direct effects are defined based on potential outcomes that are a function of exposure and mediator values. Definitions of natural direct and indirect effects are based on the comparison of 2 nested potential outcomes. And nested potential outcomes are potential outcomes that depend on the exposure and potential mediator values. This brings us to the end of this lecture.